So our first presenter for the case studies is Vincent Lesieur. He's a research scientist at CSIRO, the European Laboratory in Montpellier. CSIRO is the Commonwealth Scientific and Industrial Research Organization from the Australian government. So it's basically an European lab of the Australian government here in France. And Vincent is specialized on invasive species management, plants and insects, particularly classical biological control against invasive plants, and he's going to present about this part of his work today here.
Thank you. Yes, I'm Vincent Lesieur, and I'm working for CSIRO, as Lucas introduced. This is an Australian institution, but we have a lab in Montpellier, in southern France, and I want to thank Thibaut and the organizer for giving me the chance of talking about a topic that is not very famous in France. This is the weed biological control. By weed biological control, I mean biological control of invasive exotic plants. And I will take the example of Australia for talking about this. Just a very quick reminder to be sure we are in the same page. We are usually talking about classical biological control because the weed is usually introduced in the introduced range, in the invasive range, without its natural enemies. So classical biocontrol is to look for in the native range the natural enemy associated to the weeds and make a deliberate introduction of very specific natural enemies in the invaded range, and we expect that this insect or this mite or fungus or whatever build big population, spread in the invasive range and control the plant. So just to set the scene, in Australia, all habitats have been invaded by exotic weeds, and a recent paper estimated that the cost related to exotic weeds only for agriculture is more than 7 billion of Australian dollar per year. So this is Australian dollar, it's not US dollar, but trust me, this is a huge amount of money. And the classical biological control has a long history in Australia because it has been used for more than 100 years now. And maybe the first success is on the prickly pear, the Cactus Opuntia stricta. And the biological control was started in 1930s. And it was a massive success due to the introduction of the cactus moth. It's always nice to see the picture of before and after the introduction. And I don't know if you see very well here. This is the same plot. Before the introduction, you can see a massive infestation of prickly pear, and then just 15 months after the introduction, here, okay, the picture on the right, you can see that all prickly pear are dead. So yes, it was a massive success. So since that, almost 300 species have been released in Australia for classical biological control of weeds, and almost half of the program returned some economic benefits with an exceptional return on investment, with a benefit cost ratio of 23 for 1. If you spend $1 in biocontrol, the Australian society get back $23. But this assessment did not take in consideration the environmental benefits, because it's sometimes very difficult to assess the benefits to biodiversity, ecosystem services, etc., etc. So classical biological control of weeds is a service and is not a product. And generally, in Australia, this is funded by both private and federal investment. When I say federal investment, it's federal, but also state investment, because you know that Australia is a very big country divided into several states and territories. And with biological control in Australia, it's not CSIRO only. It's a very collaborative work. So I will try to illustrate this by the project I was hired. So it was a very big project, a multiple target project that included weeds of national significance, environmental, agricultural and aquatic weeds, but also herbicide resistant weeds. And okay, it doesn't work. AgriFuture is an Australian organization that has been set up by the Australian government, and it gathers money from different sources, mainly GRDC, which is a group of grain producer, and MLA, which is a group of meat and livestock producer. And then CSIRO was the leader of this massive project. But again, not only CSIRO, this was a collaborative work, so it means state agencies and university, but also, as Mark mentioned, classical biological control. This is vital to create a network of international collaborators. So CSIRO created a network of collaboration in Brazil, Argentina, Colombia, Europe, South Africa, and the US for this program. And after 4 years, we accumulate the results on all these weeds, and we acknowledged the founder, and they decided to stop to fund some project that was not so promising and to reallocate the funds to the most promising project. And there was a second round of funding for the most promising weeds. So we are still working on some of these weeds currently. So about the gains, classical biological control of weeds aim at reducing weed spread through reduction in seed or propagule production, aims to prevent reinvasion, aims at widespread control. This is a classic graph here you can see, because with classical biological control, we do not want to eradicate the problem, we just want to control it to a threshold, to a level that is okay for stakeholders, for farmers, for land managers, etc. So this is done by their own or through integration with other control options. And now in Australia, weed biological control is in the toolbox for weed management. I mean, it's really part of the integrated weed management. And this can lead to agricultural or environmental benefits, I mean, direct and indirect benefits. For instance, it can improve crop yield by reducing the crop density. It can also decrease herbicide application, I mean the number of herbicide application, improve the quality of life, recreational activities, etc., but also help to restore ecosystem, improve native biodiversity, etc. But as I said, sometimes it's very difficult to really assess the impact of those projects. About the contextual factors that have favored the development of this method in Australia, again, this is a classic graphic. No, it still doesn't work. Okay. Okay, this is just because I'm stupid. Yeah. Okay, so usually we do biological control at this phase when we want long-term management because the weed is too much widespread, and we want sustainable management, but also because the other methods are not effective enough. When I said other method, I mean chemical control, mechanical control, etc., but also because herbicide resistance, because of the emergence of herbicide resistance. So we need, there is a clear need for new tools. And as I said, there is a long story with high-profile successes in Australia, so this attracts the founders. So I identified two important dates, two important turning points in classical biological control of weeds in Australia. I'm pretty sure that there is more, but yeah, this is for me maybe the most important date. So here you can see the decade of release, and here in the y-axis the number of release. And the first key point is the skeleton weed success in the 70s, which was the first introduction of a plant pathogen to control an exotic weed. And this is the rust, Buccinia conrylina, and this is when the rust was released in 1971, and 5 years later, 4 or 5 years later, the problem was not a problem anymore. So this was a very massive success, and the activities, as you can see here, the activities increased in terms of weed biological control. So it was fantastic, it was beautiful, the life is so good, but then there was a significant decline in the 2000s. Especially, this can be explained by the funding for research that decreased a lot. But also because one of a project, we observe non-target effect of one biological control agent released in the US to control a European thistle that damage native and endangered North American thistle. So I think that these 2 points can explain why there is a significant decline, because it was not only for Australia, for the US, but generally speaking for weed biological control. About the risk, I think that it's important to talk about the conflict of interest, and I think that the Patterson curse, Echium plantagineum conflict of example in Australia is a good example. So Echium was a very huge problem. This is all the purple color here. It was a huge problem in the pasture system in Australia, but also for environment. And CSIRO decided to start biological control program. But there was a conflict of interest with apiarist because the weed is a honey plant and very useful for honey production. So, and the project was stopped, especially because of the High Court injunction granted against CSIRO in 1981. And to this led to the creation of the Biological Control Act in Australia, where a commission conducted an independent inquiry with a very detailed cost-benefit analysis, maybe the most comprehensive analysis done for any weed biological control program. And the commission recommended to start again the project, and the waiver was released in Australia and did a significant contribution to the control of the weed. But this changed the way of doing weed biological control in Australia, because attempting to use the act is a very complex process and very costly. So now in Australia, for a weed biological control is only approved where there is no conflict of interest, because it's too much complicated to go through the act. So yes, of course, there is a major obstacle encountered in the past, but also in the present and in the future. And I think that the biggest problem is the funding, because if there is no funding, there is no project. The scientific controversy. Yes, in Australia there is some controversy, yes and no. As I said, with the project, with the example in North America about non-target effect, but this led to more rigorous testing, more rigorous procedure to test, to try to predict the non-target effect. And there is a continuous improvement of the method by incorporating new and emerging techniques such as genetics, genomics, modeling, etc., etc. And the challenge for the future, as I said, the funding, it's still a challenge. But maybe to include the climate change in our project is also a challenge, because we know that climate change can impact the weed, but it can also impact the biological control agent. Maybe the Nagoya Protocol can also be a challenge, not a problem, but a challenge, because we have to consider it when we want to implement biological control. And I call this the new version of biological control, the genetic control. Currently at CSIRO, not in France but in Australia, there is an internal investment of CSIRO to try to reply to the two questions about the feasibility of genetic control and the acceptability of genetic control. Because Australian people are pretty open to biological control, but are they ready to make some genetic control? This is one of the questions we will try to reply with this program. So I want to thank you for your attention. I don't know if we have time for questions. I don't know if you have some question, but I have a question, to be honest. I do all the steps. I did the presentation, the question, and I will try to answer to my question. So in France, are we ready to try the method? I think we are at a turning point, so maybe it can be something done in the future. Thank you.
Hi, good morning. Thank you for your good presentation. I have a question regarding the non-target effects against other crops. How do you measure that?
The non-target effect I mentioned was from an old program, an insect that has been released in maybe in the 50. And now we included in our test, in the host specificity testing, all major crops every time. So, for instance, if you want to test a species to control, I don't know, a species that is related to the Eliante tribe, you will include the sunflower in your test. You will include all the crops closely related, phylogenetically related to the target. So yeah, this is one of the way we test the specificity of our insect, of our fungi, and this is it works very well. To be honest, even in the lab, test lab, it works very well.
Thank you.
Thank you. I have just two small questions, just to make sure I understand well. CBC is okay in Europe for insects, but not for weed management?
Yeah, because of the perception of the people, especially in France, when you say, okay, I'm working on weed biological control, people say, oh, okay, you are the devil. No, I don't want to talk with you. And we don't know why. We are trying to understand why there is this kind of dichotomy. When you are talking about, when you want to control a pest, the pest is the problem, but the weed, people are always afraid we will introduce the next pest, the pest for tomorrow.
Okay. And the other one, just to make sure I understand well, where you were talking about genetic control at the end, it's the autocidal control, or it's something different?
No,
I didn't get that.
I'm not a specialist of this, but to use, for instance, gene drive, to use for the gene silencing or this kind of stuff, yeah.
Maybe just a comment. I don't think that the classical biological control of weed is prohibited in France. It is just that it would be
no, it's not prohibited.
Difficult to have funding to do such a things. And with regard to the regulation of 2012, we have never tried to apply for a permit for an exotic biological control agent against a weed, I think.
No, never.
So,
except in La Réunion Island.
Yeah, except in overseas territories.
Yeah.
Exact.
Hey, regarding the genetic control and the non-target effects, I'd just like to underline that those non-target effects go way beyond those biological effects. There's also the type of society and the type of technology that people want to have for the future of agriculture. And that's probably one of the reasons why the public is reluctant to accept these type of technologies. And for those interested in non-target effects, there's an amazing network of people, interdisciplinary network on non-target effects in France. And you are all welcome, and there's already a number of people there in the room who participate.
Thank you very much, Vincent.